All right, hi guys. So today I'm going to go over a ball ramp lab with you. You should have your do now questions done at this point. Excuse me. So they're embedded in your Play Posit video. So hopefully you'll get those as a little review from yesterday. This I wanted to show you because it goes right along with our forces in motion unit, and this is something you're going to have to do on your final exam. The first thing that I want to go over with you, the most important thing that you have to keep in mind when you're doing these stations at the end of the year is to read the directions. I don't know if it's done on purpose just to make sure that you follow directions, but some of the things on here, which we'll go over, they're actually, you do more work if you don't follow the directions. You could see right here on this front page, there's a data table right here. And then there are 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 questions. Now, a bunch of these questions have to do with filling out the data table. So if you don't read the directions, you're going to fill out the data table, then answer the questions, you're doing twice as much work. Okay, so reading directions is really the most important thing that you can do. There's going to be station diagrams at every station that you work at. I'll show you the one for this one. This is a station diagram. This is how it should look when you come and sit down at the station. And this is how it should look when you leave the station. So you'll have a block with a ruler and a cup. I took a picture of mine so I can show you, and then a golf ball in a bag. The mat with a measuring strip is going to, obviously this is going to look a lot different looking down on it, but this is how the station should look when you get there and when you leave, okay? Scrolling down, this is what the station will look like from your vantage point. We've got a cup here. This is the starting point. It says it right on there, the ending point for the ruler. And then this is our measuring strip. This is a block that the ruler is resting on, and this is where you would release a golf ball. You're releasing the golf ball down the ruler, it hits the cup and moves down this measuring strip, and you record how far it goes. So this is how it should look when you sit down, and this is how it should look when you get back up again, when you leave the station. So the first thing that you have to do is be sure that the cup is on the starting circle with the opening facing the end of the ruler. So you want it facing this way so that when you roll down, it hits, the ball goes right into the cup. Take the golf ball out of the bag. That's number 2. So again, reading directions, you know that you don't have to really do much at this point. Place the ball on the ramp so the middle of the ball is at the 15 centimeter mark. So when you see your ruler, excuse me, you're going to place it at the 15 centimeter mark, so the ruler should start at 0 down here, 15 centimeter mark, and then let it go. You want to make sure the edge of the golf ball is at the front. The front of the golf ball is at the 15 centimeter mark. And then you're just going to release it. Now, when you release it, no pushing. You're just going to let the ball go and let it roll. And then it says number 4, you're going to record where it moved to on the strip. So you're going to look at the strip, make sure, we'll do some more practice with how to read rulers, because I think some of you need some practice on that, which is fine. But you can see that between 15 and 16, you'll be able to see when you get closer, there's 10 hash marks. So make sure you're using decimal places to the nearest decimal. You can see that they use 1 decimal place, so you want to use 1 decimal place in your answer, and then put your units, convert your units down. Now, as we continue on, you can see in this data table that you release it at all these different points. There are 3 points that are going to be the same. When you release it, well, actually, before I go into that, you can see down here 5, 6, and 7, they're just telling you to go ahead and fill in this data table. So first you're going to do it at the 20 centimeter mark, and then the 25 centimeter mark, and then you're going to do it 2 more times from the 75 centimeter mark. So you're going to do it 3 times from the same mark. Now, this last part is going to be important to have accuracy, because what it should show is that it's not perfect every time. The cup moves a slightly different length every time you release it. And there's reasons for that. And we talked a little bit about this in the beginning of the year. Number 8 says you probably found that the cup traveled slightly different distances when you released the ball 3 times from the 25 centimeter mark. Give 2 reasons that might explain why the cup did not stop at the exact same spot each time. If you recall, in the beginning of the year when you guys did the gummy lab, you talked about at the end what could have possibly happened. This happened in the gummy lab and another lab we did. What could have possibly happened that might have changed your data? So any kind of human error, okay? So reasons, I want you to think quickly about any kind of reasons that even though I'm releasing this at the same exact point every time, why would that cup go a different distance? I want you to think about that for just a minute. Try to answer this question, and then when we come back, we'll go over some possible reasons. And what I want you to think of is human error. Human error. Okay, we're not perfect. So what could we have done that made that mark a different spot every time? So first reason, second reason. Some of the things that you could have possibly put down is, hey, I bumped the table. Maybe I bumped the table. It moved and my ball went a different distance. Another possibility is I pushed the ball a little. Okay, if you're just supposed to release the ball, maybe I pushed it. Maybe there's a little bit more force behind that ball. It accelerated faster and the cup moved. Another possibility is that I didn't put the cup back right where it should have gone. Another possibility is that when I moved the ball, I didn't release it from the same exact point. So all these things, like I said, this is all human error. These are possibilities that could have happened while you were trying to do your lab, and because you're not perfect. So that's what those questions are asking. The next part, the back part of this page, this is another instance where not paying attention to the directions will make you will create a lot more work for you. So you can see here it's you're designing an experiment. You have to think about what you would do to design an experiment. You want to study how changing the mass of the cup that moves will change the distance it is moved by the golf ball. Assume that the setup it will be the same and the data table is here, but look at this. Do not actually fill out the data table. You're not supposed to do anything with this data table. It's just supposed to be like a visual for you for reference. What would you recommend about the release point of the golf ball each time a new cup is tested? This is, again, going back to the beginning of the year when we were talking about variables, okay? How many variables should you change in an experiment at any given time? The answer is 1. So right now, what we see when you did the first part of the experiment, you were changing, the variable that we were changing was the distance on the ruler. In this second experiment, the mass of the cup is changing. This is the only variable that should change. So it's asking, what would you recommend about the release point of the golf ball each time a new cup is tested? Because the mass of the cup is changing, the release point should remain exactly the same, because you're only changing one variable in an experiment at a time. You want to know how much the mass of the cup is going to change the distance the cup moves. So you have to release it from the same point every time so that you can see what the mass of the cup does to the experiment. Okay? Now, write a hypothesis about the distance the cups the distance the cups of different masses will be moved by the golf ball. Hypothesis, this is another flashback to the beginning of the year. Hypothesis should be written as what kind of statement? If you said if then, you're absolutely right. It also should be in the form of what? A question. So, when you are answering your question, your hypothesis, your if-then statement, if I change the mass of the cups, then this will happen. So that's your entire hypothesis. and then you're just resetting all of your materials and you're done with that station. Now you get 15 minutes per station. This should not take you that long, okay? I'm going to show you in the next video how it actually will play out, but this whole thing should not take you that long, and you should have plenty of time to read through your directions before you even get started.